In this example, what we want to do is use what we know about inverse trig functions to try and solve this inverse trig equation. So our goal is to isolate our inverse trig function and ultimately isolate our variable. So what we want to do is we want to start by just trying to get inverse sine of x by itself. So we know that this 3 is multiplying the inverse sine. So let's divide both sides by 3. Divide by 3, and we end up with the inverse sine of x equals pi over 3. Now we're trying to get x out of the argument for this inverse sine. And if you recall, if you compose a function with its inverse, you will get the argument as a result. So what we're going to do is we're going to take the sine of both sides. Take the sine of both sides. And then by taking the sine of both sides, these kind of cancel each other out, and we end up with the argument. So we get that x equals the sine at pi over 3. If you think about the ordered pair at pi over 3, it's going to be 1/2 and then rad 3 over 2. And then again, we're talking about the sine here, so it's the y-coordinate. So x is equal to the square root of 3 over 2. So that is going to be the solution to this equation. Let's take a look at another example. In this example, we want to find the exact value of 4 times the inverse cosine of 5x equals pi. So again, our goal is to isolate the x, but before we can do that, we need to isolate our cosine. So let's divide both sides by 4, divide by 4. So we end up with the inverse cosine of the quantity 5x equals pi over 4. And just like we did last time, in order to get the argument out, we're going to take the cosine of both sides. Take the cosine of both sides. And we end up with 5x equals the cosine of pi over 4. Now, before we divide by 5, what we should do is evaluate the cosine of pi over 4. At pi over 4, we get the square root of 2 over 2, comma, the square root of 2 over 2 as our ordered pairs. And we're talking about the cosine, so it's the x-coordinate. In this case, they're actually just both the same. So we have that 5x is equal to the square root of 2 over 2. And then divide by 5, which is the same as multiplying by 1/5. So multiply by 1/5. And we get that x is equal to the square root of 2 over 10. And that's the solution to that trig inverse equation. Let's take a look at one more example. In this example, we want to find the exact value of this trig equation. Now, in this case, we have some inverse cosines on both sides, and then we have the 3 pi together with that. So what our goal is to get the thing that looks like it's an angle measure on one side, and then all of our inverse cosines on the other. So I'm going to add 3 pi first. Add 3 pi. And that's going to give me, so add 3 pi here. That's going to give me 6 inverse cosine of x equals 2 inverse cosine of x plus 3 pi. Now, because these both have the same argument, we can treat them as like terms. So we can subtract 2 inverse cosine of x from both sides. And those will cancel. 6 minus 2, that's going to be 4. So we have 4 inverse cosine of x equals 3 pi. Divide both sides by 4. Divide by 4. And we get that the inverse cosine of x is equal to 3 pi over 4. So now, just like we've done in all of our other problems, in order to get the argument out, we want to take the cosine of both sides. So we're going to take the cosine of both sides, and we're going to get that x equals the cosine at 3 pi over 4. The ordered pairs at 3 pi over 4 are negative square root of 2 over 2, and then positive square root of 2 over 2. This is the cosine, so it's going to be the x coordinate. So we get that x equals negative square root of 2 over 2. And this is the solution to our given trig equation.